semiconductor manufacturing industry is the cornerstone of present-day electronics and technology manufacturing. It is propelled by the notion of always creating better, smaller, faster chips, an ideal put forth by a founding father of the industry, Dr. Gordon Moore, the recipient of the 2008 IEEE Medal of Honor.
A peculiar thing about the semiconductor industry is by making things smaller, the next generation of technology, you make them better, you make them faster, lower power and all kinds of things, but you also make them cheaper. That doesn't happen many other places, so you can't fall far behind the leaders in the industry and still be economically competitive.
Dr. Moore, Chairman Emeritus and co-founder of Intel, philanthropist and environmentalist, has been at the helm of electronics and technology for 50 years. He is most notably known for authoring Moore's Law, which states that the number of transistors on a chip will double about every 2 years. Moore spearheaded research and development of the first microprocessor, which laid the foundation for today's complex chips.
Well, that was the big breakthrough, because there'd always been this idea that someday we'd put a computer on a chip, but that day was always far in the future.
That future has been the cornerstone of the computer industry for decades. In recognition of these achievements, IEEE is honored to award Dr. Moore the 2008 IEEE Medal of Honor for his contributions during an illustrious career. In addition to making predictions for the industry, Dr. Moore co-founded 2 companies, both of which have set standards for innovation.
I have to consider the formation and success of Intel as my greatest achievement in the industry. When we started, our goal was survival, to grow big enough that we could be a participant. And Intel has become the largest and most profitable semiconductor company since then. And I like to feel I played a role in that development, and I'm proud of the company and the way it's developed and the way it's continuing to be a major participant in the industry.
It is perhaps ironic that someone whose name is practically synonymous with the integrated circuit began his career not as an engineer, but as a chemist. Dr. Moore earned a bachelor's degree in chemistry from the University of California, Berkeley in 1950, and later a PhD in chemistry and physics from the California Institute of Technology.
I was a physical chemist, and fortunately I got into the semiconductor industry at a time when the science wasn't well understood.
In 1956, Dr. William Shockley started the Shockley Semiconductor Laboratory and invited Dr. Moore to join him in Mountain View, California.
What he wanted to do really struck my fancy. He was after making a very practical device, a silicon transistor, and it looked like it could use some of the skills I had developed as a chemist. I knew absolutely nothing about semiconductors or electronics in general, but that wasn't a requirement at that time. There were many other things that still had to be solved where my background did fit.
A year later, Dr. Moore was part of the traitorous 8 who quit Shockley Labs to co-found Fairchild Semiconductor. They developed the planar transistor, the planar process which laid the foundation for the first practical integrated circuits on wafers. Fairchild went on to be a leader in the world of integrated circuits. In 1968, Dr. Moore and Robert Noyce left Fairchild to start a new company, initially named NM Electronics. It grew to be the world's largest semiconductor company, a company that we know today as Intel, short for Integrated Electronics. At first, they focused on semiconductor memory, and their first success came in the form of I-1103 DRAM. Intel later followed with the EEPROM, the first erasable programmable memory device, but it was in 1969 that opportunity came knocking at Intel. Nippon Calculating Machine Corporation approached Intel to design multiple custom chips for its new Busicom 141PF printing calculator.
They had designed on paper, I think it was 13 different chips all quite complex, that they wanted to find a semiconductor company to make. We looked at that, and we were very interested in doing the calculator, but we didn't have an engineering team big enough to even think of tackling the design in silicon of the 13 chips. But one of our guys, who we had hired, who had a fair amount of systems experience, said, gee, you know, I think we can do all of these calculators with a general purpose computer architecture, and it shouldn't be more complex than our memory chips.
Enter the age of the microprocessor. And in 1971, the programmable chip Intel 4004 became the first general-purpose microprocessor on the market. Others in the industry were coming out with the next generations of microprocessors, each one with more components and speed, as Moore had predicted in 1965. Moore had written an internal paper at Fairchild Semiconductor called The Future of Integrated Electronics to forecast the direction of the integrated circuit industry. A year later, a version of this paper was published in the 35th anniversary edition of Electronics magazine with the title Cramming More Components onto Integrated Circuits. In the paper, Moore proposed that the number of components per chip would double every 12 months. In 1975, Moore revised his prediction based on industry growth to a doubling of components every 2 years. Dubbed Moore's Law, this statement became a milestone that any company in the electronics business has to keep up with, or risk losing out to the competition. Moore's Law has influenced not only design, but economics as well.
All I was trying to do was get that message across, that by putting more and more stuff on a chip, we're going to make electronics cheaper. I'm not thinking it was going to be precise, but to get the idea across, things are going to get a lot more complicated, and therefore electronics are going to get cheaper. And instead of the 10 doublings I'd predicted, I think we only got 9, but it was close enough that somebody dubbed this Moore's Law. Now, I changed it in 1975 because we were losing one of the factors that had allowed us to increase it that fast, and I said, whoops, it's only going to double every 2 years. And it turns out I was a little pessimistic on that one. We beat the 2 years. But this exponential expansion of complexity was originally Moore's Law. But everything now that grows exponentially is blamed on Moore's Law, so I'm happy to take credit for all of it.
Dr. Moore received the National Medal of Technology in 1990, and in 2002 received the Presidential Medal of Freedom, the nation's highest civilian honor. But his achievements do not stop with the electronics industry. Moore is an innovator in business management as well.
Communication is so important up and down an organization. You get it easiest by having a fairly flat social organization, even if it's hierarchical on a chart. For example, no reserved parking places. If you want to park close to the building, you get to work early. We had a short period where we built a new building and had enclosed offices for the professional staff. Then we started to grow a lot and decided if we did that again, it would look like jail cells. We'd have to have so many offices, so we decided to go for the open landscaping. I still have the biggest cubicle at Intel in spite of the fact that I don't come in here very often anymore. And the reason is I had a wooden table from my previous office that I wanted to keep, and it was larger than would fit in the standard Intel module, so they made me a somewhat bigger one.
This open structure in the organization is conducive to the generation of new ideas and opening thinking. Dr. Moore thinks it's imperative for people in the industry to try thinking differently and come up with new approaches.
Well, it's important to think outside the wafer, I guess I'd say, in our industry. The industry is founded upon creative contributions by a variety of people. And both the creativity and the channeling of the creativity in practical directions proves to be important.
Dr. Moore would like to extend that advice to young engineers eager to make their own mark on the industry, following a well-founded education.
The only way you learn the new things is by having a very strong basis of the simplest things.
And it is an appreciation of the simple things that is at the core of the Moore Foundation, a philanthropic organization established by Dr. Moore and his wife of 58 years, Betty. Since 2000, the Moore Foundation has supported several main areas of interest: environmental conservation, investing in science research, innovation and education, nursing, and the quality of life in the San Francisco Bay Area, where both Dr. and Mrs. Moore grew up.
I was fortunate to be able to set up a foundation to give back to society some of the things that I've been fortunate enough to acquire.
Avid outdoors enthusiasts, the Moores have traveled to many remote places which are now under threat of land development. The Moore Foundation is one way they can help save these endangered lands.
I think what got us involved in conservation first was our experience with some relatively remote places. My wife and I like to go fishing, and the best fishing is always someplace where there aren't a lot of people. We started going to Baja California, and it got too civilized for us, so we moved on to Central America and so forth in our fishing. But what we found is a place that was remote and natural one year would be high-rise hotels and golf courses a few years later. All of the natural places in the world were changing, and in the process a lot of the things that were there were being destroyed and could never come back. So this got us involved initially in some of the conservation efforts. And of course, over the last several years, the way we're hurting the earth are becoming increasingly apparent, from global warming through loss of species and the changing climate. There are a lot of things that I think we can still have a significant impact on.
Another area of impact for the Moore Foundation is supporting innovative scientific research.
A foundation can take a much riskier approach than a government agency can in funding things. So we've been able to invest in areas that were exciting, I hope are important, where we've been able to stimulate work and get it going and have other people come in and expand it where we've been successful.
Finally, education is another crucial aspect of Dr. Moore's philosophy. Moore's Foundation is actively involved in improving K-12 education in the San Francisco Bay Area.
In fact, I think the biggest separation in the U.S. society is between the educated and non-educated, and I think that's going to grow rather than shrink. And this is education at all levels. The U.S. still has the premier high education, the best graduate schools, universities in the world. Our K-12, on the other hand, leaves something to be desired.
Today, Dr. Moore spends his time enjoying his hobbies, namely fishing and golf, admitting that the former is more about collecting fishhooks. He still enjoys a new technology, even in the form of gadgets. For example, the Sky Scout that aids his curiosity in astronomy, and a GPS device for golf that calculates the distance to the next hole. But does it improve his game?
No, it takes more than that to improve my game, but it speeds up my game.
But one game Dr. Moore's always excelled in has been technology. From early chips with 60 components, to the first microprocessor, to the Intel Core 2 Duo with 291 million transistors, the companies Dr. Moore co-founded dominated the world of semiconductors for decades. His legacy, no doubt, will live on for many more.